All right, so here we are building towards being able to draw Lewis structures. Lewis structures are going to be crucial for us to be able to draw in order to get to exploring molecular geometry in Chapter 10. So that is why I started us with Chapter 9, just to build towards that. So we are all on the same page as we jump into Chapter 10. Okay, so in order to begin to draw Lewis structures, the first thing we need to know how to do is to count valence electrons in a molecule or a polyatomic ion. That's the first step. And so here we have methanol. We have a molecule of methanol, and here's the chemical formula of methanol, CH3OH. The question is, how many valence electrons are in the methanol molecule? Well, does anybody know what a valence electron is? A valence electron, by definition, are those electrons located in the outer energy levels. Okay, the electrons available for bonding, chemical bonding. That is why they are important. Well, it's very easy to determine the number of valence electrons in an atom because it follows a pattern on the periodic table. So, for example, if I want to know an atom of hydrogen in its ground state, just a normal atom of hydrogen, how many valence electrons would it have? Well, I look at the periodic table and I say hydrogen is in group 1. So it has 1 valence electron. Well, what about an atom of fluorine? Well, I'd have to go to the periodic table. And if I'm counting the main groups, this is group 1A, this is group 2A, 3A, 4A, 5A, 6A, 7A, and the noble gases are group 8A. Fluorine is here in group 7A, one of the main group elements, and so it has 7 valence electrons. Boron, 3 valence electrons in ground state. Oxygen, 6 valence electrons. So it's very easy to determine the number of valence electrons for an atom. And we can apply that same principle here in this example. All I need to do is determine which atoms are present and how many of them I have and count up the total valence electrons. So let's begin by determining which elements are present in this molecule of methanol. Well, I have carbon. How many carbon atoms? Just 1. I also have hydrogen. But the question is, how many hydrogen atoms? Well, I have 1, 2, 3, plus another one here. So that would be 4 hydrogen atoms. I only had 1 carbon atom. I have another element present as well. That's oxygen. How many? Just 1. Okay? So now let's count total number of valence electrons. Well, how many valence electrons does every carbon atom have? Let's find carbon. Here it is. It's in group 4A, so it has 4 valence electrons. How many carbon atoms do we have? Just 1. So I just have 4 valence electrons. What about hydrogen? Well, I have 4 hydrogen atoms. How many valence electrons does each hydrogen atom have? It's in group 1A, 1. Okay, so if it's 1 each, and I have 4 of them, then I have a total of 4 valence electrons from those 4 hydrogen atoms. I also have 1 oxygen atom. Each oxygen atom carries a total of 6 valence electrons that can participate in bonding. Okay? 6 valence electrons from this 1 oxygen atom. So let's tally them up. 6 plus 4 is 10, plus another 4, a total of 14 valence electrons. And that's it.